Hello there. In this video we're going to discuss how you can use the unit circle to evaluate the values of trigonometric functions, sine, cosine, tangent, secant, cosecant, and cotangent at pretty much any angle, such as 30 degrees, 60 degrees, 120 degrees. Any angle that is a multiple of 30 or 45 or 6 degrees you can figure out with the unit circle. You can also get a lot more than that, like the 15 degrees and thirds of that if you're really clever, but we're not going to focus on that here. So we're going to be pretty much focusing on the basic angles. So I'm assuming that you already know how to construct the unit circle. For example, this point is going to be equal to the square root of 3 over 2, comma 1/2. This point right here is going to be square root of 2 over 2, comma square root of 2 over 2. This point right here is going to be 1/2, comma square root of 3 over 2. And this is going to be a unit circle, so this is going to be 1, 0. This point is 0, comma 1. And these angles that we have here, this is going to be 30 degrees. Next is going to be 45 degrees. This is going to be 60 degrees. And of course we have our 90-degree angle. If you do not know where these numbers come from, do not worry. This video is just for reference on how to use this unit circle once you are able to derive it. So most likely, if you have a unit circle memorized, or you're just using one as reference in order to do a quiz or some homeworks, or just some reference in the industry, you most likely have all of the angles in quadrants 1, 2, 3, and 4, all of the points both positive and negative, as well as the radian and degree measurements for all of the angles of reference. So for example, 30 degrees is the equivalent to saying pi divided by 6, 45 degrees is the same as pi divided by 4, and 60 degrees is the same as pi over 3, and 90 degrees is the same as pi over 2. And if you do not know how to convert between radians and degrees, I definitely should reference you to a video that actually goes through that. But let's assume you have all of that in front of you so that you do not have to convert at the last moment. Let's figure out how to evaluate some trig functions at some angles of interest. So as our first example, consider let us assume theta is equal to pi over 2. So what we're going to do is we're going to do sine, cosine, tangent, cosecant, secant, and cotangent for all the angles for which I list. So let's figure out what the sine of pi over 2 is equal to. So sine of pi over 2, so where is that going to be located? So pi over 2 should be located right here on our 90-degree angle. So as we all know, this coordinate is the point 0, comma 1. So if you do not remember how to use the reference of the unit circle, so remember the x coordinate is cosine and the y coordinate is sine. So cosine theta, comma sine theta. So 0 is cosine and 1 is the sine value for that angle of interest. So that means the sine of pi over 2 is going to be the y coordinate, which is going to be equal to 1. Cosine of pi over 2 is going to be the x coordinate, so that's going to be 0. Tangent of pi over 2, as we know, is going to be equal to sine of theta divided by cosine of theta for that particular theta. So that's going to be 1 divided by 0, which does not exist. So let's do the other three. So cosecant of pi over 2, as we know, is going to be 1 divided by sine of pi over 2. So that's going to be 1 divided by 1, which is 1. Secant of pi over 2 is going to be 1 divided by cosine of pi over 2. Cosine of pi over 2 we've already found to be equal to 0, so this does not exist. And if we have cotangent of pi over 2, well, we should know that this is going to be equal to cosine theta divided by sine of theta. Cosine theta is 0, divided by sine of theta is 1, so that's going to be equal to 0. So this is how to use that particular one point to tell you the value of all the 6 trig functions at that particular angle. So let's work through another example. So let's assume theta is equal to 2 pi divided by 3. So if you have your unit circle already filled out, then you should be able to quickly identify where this point is. But let's assume you don't. So all your pi over 3's are going to be your 60-degree reference angles. So pi over 3 is going to be located over here, which means 2 pi over 3 is going to be located there, and 3 pi over 3 is going to be located there. So technically it should look more like that, where all of these angles are the same, let's assume. So what exactly will that be? So let's draw my little circle here to make it a little bit more neat. So my 60 degree is there and there. So remember, my 60-degree angle in quadrant 1 is the point 1/2 comma square root of 3 over 2, which means this point is going to be pretty much a mirror image, namely negative 1/2 square root of 3 over 2. So that's going to be my 2 pi over 3 angle, or my 60-degree reference angle to the negative x-axis. So using this point, let's figure out all the 6 trig functions. So sine of theta, so cosine x sine y. So sine is the y-coordinate, so this is going to be square root of 3 divided by 2. Cosine theta is going to be the x value, so that's going to be negative 1/2. Cosecant of theta is going to be the reciprocal of sine, so that's going to be 2 divided by the square root of 3. Secant is going to be the reciprocal of cosine, so that's going to be negative 2 over 1, or just simply negative 2. Tangent of theta is going to be sine divided by cosine, so that's going to be square root of 3 over 2 divided by negative 1/2, which you can find to be equal to negative square root of 3. And cotangent of theta is going to be equal to the reciprocal of negative root 3, which is negative 1 over root 3. And some people will rewrite that as negative root 3 over 3. So, example 3. Let's assume we have theta is equal to negative 5 pi divided by 6. So your pi over 6's are your 30-degree reference angles, and if we go in the negative direction, that means we're moving clockwise. So if we're at negative 6 pi over 6, that means we're at 180 degrees in the negative direction, so that means negative 5 pi over 6 is going to be located there with this reference angle of 30 degrees. So if we sort of mirror this into quadrant 1 and draw a circle completely around, so this point right here is going to be, of course, square root of 3 over 2 comma 1/2. So this is going to be the mirror image of that, which is going to be negative 3 over 2 comma negative 1/2. But if you have your unit circle already figured out, then you should already know this. Alright, so let's figure out all our trig functions. So sine of theta is going to be the y value, so negative 1/2. Cosine theta is going to be the x value, negative root 3 over 2. Cosecant theta is going to be the reciprocal of sine, so that's going to be negative 2. Secant theta is going to be the reciprocal of cosine, so negative 2 over root 3. Tangent of theta is going to be sine over cosine, so negative 1/2 divided by negative root 3 over 2, which is going to be positive 1 over root 3, or root 3 over 3 if you don't like radicals on the bottom. And of course, cotangent of theta is going to be the reciprocal of 1 over root 3, which is just going to be equal to root 3. So let's focus on some angles. So let's assume theta is equal to 225 degrees. So 225 degrees, so where will that be? So 180 degrees is here. And if we add 45 degrees to that, 45 degrees plus 180 degrees is going to give us 225. So 225 is the 45 degree angle in quadrant 3. So as we all know, that's a symmetric point to this point over here, which as we know is root 2 over 2 comma root 2 over 2. So it mirrors into quadrant 3 as negative root 2 over 2 comma negative root 2 over 2. So sine of theta is going to be the y value, negative root 2 over 2. Cosine of theta is going to be the x value, which is the same by coincidence, negative 2 root 2 over 2. Let's see, cosecant of theta is going to be the reciprocal of sine, so that's going to be equal to negative 2 over root 2. And you can rationalize and say that that's actually a pretty number. Similar for secant, so if we multiply top and bottom of this by root 2, you can see it's actually the same as root 2, of course, negative root 2. Also, tangent. Sine and cosine are the same, both in terms of sign and value, so when you divide them, that's just going to give us 1. And the cotangent of that is going to be 1 divided by 1, which is of course equal to 1. So example 5, let's assume theta is equal to negative 240 degrees. So what is negative 240 degrees? So how can we get to a multiple of 360? So if we take, let's see here. So this is going to be negative 180 degrees. This is going to be equal to negative 270 degrees. So clearly it has to be somewhere in this quadrant since we're rotating clockwise. So since this is going to be negative 270 degrees and this is negative 240 degrees, this distance between here and here is only 30 degrees, which means the distance from this angle and the x-axis has to be 60 degrees. So whatever this is, it's going to be a 60-degree reference angle in quadrant 2, which is the same as 120 degrees, which you can easily verify because 360 minus 240 is going to, of course, be equal to 120 degrees. So the value of negative 240 and 120 are the exact same thing. So if we focus on 120 on our unit circle, oh, my line turned green, that's cool. So let's focus on this angle now. So 120 is there. So 60 degree is my point of interest. So that's going to give us 1/2 comma root 3 over 2. So this is going to be negative 1/2 root 3 over 2. So sine of theta is going to be my y value. Cosine theta is going to be my x value. And I leave as an exercise to find the other 4 angles as well. Same procedure. So what about 570 degrees? So 570 is above 360, so I'm just going to subtract 360 from the start just to see if I can figure out what angle this is. So 5 minus 3 is going to be 2, 1, 0, so I get 210 degrees. So as we know, 210 degrees is 30 degrees more than 180 degrees. So if that's the case, then my 30-degree reference angle is the only thing that I'm going to be focused on. But if you have your unit circle already filled out, you do not need to do any of these calculations really. You just need to figure out what's it equal to. So 30 degrees, as we know, is root 3 over 2, comma 1/2. So therefore, cosine of theta is going to be x, root 3 over 2. Sine of theta is going to be y, 1/2. And you can figure out the other 4 angles on your own as an exercise. But this is just a demonstration on how you can use your unit circle to evaluate the 6 trig functions at any angle that is a multiple of 30, 45, or 60 degrees.